We are beginning lesson C, which is the study of exponents and scientific notation in Math 8. Lesson 1 is discovering the rules of exponents. So your I can statement is to determine the properties of integers and exponents using prior knowledge, and we're going to look at patterns. It says in this unit you'll be learning about exponents and scientific notation. Today we're going to start with our exponents. What is an exponent? And I want you to think about this and what you know about exponents and what we've worked with already. Mostly we have worked with the exponent of 2 and 3 so far this year. If you think of our problems earlier this year, here is our exponent. We have 3 to the second. We could have 4 to the second. The 2 is our exponent. We could have 4 to the third power. So when we've memorized our squares and cubes earlier this year, the exponent is this little number written up above. Now, sometimes people like to say it's the smaller number, but if you're thinking about it and you look at this problem, and if I have 2 to the third, it's not really the smaller number, it's the number that's up above. So, what does that exponent do? The exponent is used to show repeated multiplication. So that is our key thing that we want to be thinking about. It is always showing repeated multiplication. Okay? So when I talk about repeated multiplication, we're talking about that exponent. What is it showing repeated multiplication of? It's showing repeated multiplication of the base. The base is the number, like if we were looking at our base would be 3, 4, 4, and 2. So that when we look at 4 to the third, what does that mean? It means it's showing us to multiply 3 times the base 4. So the exponent tells us how many times to multiply. And when I think of the number of times, in this case, it would have 3 4s. If we're looking at 2 to the third, it's not necessarily the smaller number because of 2 and 3. 2 is smaller. So it's showing that we are going to repeat multiplying 2 3 times. So our exponent is here, the base number, and this whole thing is a power. Many of your first assignments, I'm going to always ask you to leave your answer as a power. A power is when you have a base and an exponent. So what are some of our vocabulary we're looking at? A way of represented repeated multiplication. So a way of representing that is our power. The number that's being repeatedly multiplied, in this case, which number is repeatedly multiplied is the ace. That is our 8 is our base number. The number of times that the base is being multiplied by itself, that is our exponent. Now, one of the most confusing things is that people often think the way of representing this is just the exponent. It's not. It's the whole power when we take a look at that. What you're asked to do now, and I'll kind of have you pause the video after I do the first couple so that you can see it, and then you'll start the video again. But when we look at this, it says complete the table and look for a pattern. So the expanded form means showing me the multiplication. So if I'm doing expanded form, this is what I want to look for. I'm looking for 2 times 2, because that's 2 to the second. And now I'm going to look for 2 to the fourth. So that means I need to have 4 2's. It says how many factors do you have? How many, in this case, 2's? And we have 6. So how could we write how many 2's we have? We could write it as 2 to the 6th power. I want you to try it with the next couple. Pause the video. Think about what that 3 to the 3 is telling us. Think about what 7 to the second, 7 to the third, x to the sixth. Here's one you haven't seen before. If there's no exponent, what is understood to be there? Most mathematicians always believe that it's a 1. And then you have y to the second, x to the second times y to the third. I want you to try these on your own, and then we'll pause the video and we will take a look at that. You should now see the expanded form. In each one, if we're looking at the number of factors, here we have 4, here we have 5, here we have 7, and here we have 5. Now this last one is just a little different when we look at our answer. Here we are definitely going to say our answer is 3 to the fourth, 7 to the second, and 7 to the third. Since it's the same base, we can write it as 7 to the fifth. Here we have 7 x's. Since they're all x's, our answer is going to be x to the seventh. And this is the tricky one. You cannot combine these and put to the fifth. So you're going to leave it separate. It's going to say x to the second, because that's our one base, and y to the third is how we simplify that product. So if we're going to look at that pattern, it says, how are the numbers in the first and last column related? What pattern do you see? So if you were looking at this table, what do you see as a pattern? So we know it was 2 and 4, we got 6. We had 3 and 1, we got 4. 2 and 3, we got 5. 6 and 1, 7. What does it look like is happening with those exponents to get the factor in the middle? Some of you are probably already thinking and could probably write this, and here's what it is. If you add the exponents in the original column, you get the exponents in the last column. Now, that's actually called simplifying. So anytime we have a problem like this, and it says practice writing the problem as a single power using this pattern, what we want to take a look at is that we want to get our answer. So I'm going to do the first one, and then I'm going to have you pause the video, and I want you to try the next two. So 10 to the fourth and 10 to the 1, this is what we are thinking. 4 plus 1, I won't need you to write that down all the time. And 10 to the fifth is our final answer. I do need to be able to tell that I have a base and an exponent. I don't want to see the number 105. Please try the next 3, and then we will unpause the video so you can see what those look like. Now, if you pause the video again if you need to at this point, but this one was not meant to be a trick question, but when the bases are not the same, you cannot add the exponents. So really only in the first and the third one can you actually add those exponents to get that answer x to the eighth. This one, again, you have 2 different bases. So always to be aware that if the base is not the same, this rule does not apply. Here's another pattern I want you to look at. Again, we want to do the expanded expression. The expanded expression means show me the multiplication. So if I have 2 to the 8th and divided by 2 to the 3rd, I want you to write down all those 2's. So I have 3, 4, 5, 6, 7, 8. Divided by 2 to the 3rd. Notice our base is the same, even though our exponents are different. It says, well, how many factors of 2 will be remaining? And what you want to think about is that 2 divided by 2 is actually 1. These 2 divided by 2 would be 1, not 0. Some of you always tell me 0 is 1. And how many 2's do you have remaining? Number of factors, 5. It says what's going to be our answer? 2 to the 5th. Notice it only works when our base is the same, so this last one's going to be just looking a little different in our answer. I want you to try right now, pause the video again, write out the expanded form of each one, and try and look at the number of factors, and then we'll do the last column together. You've now unpaused the video. Hopefully your work looks a lot like mine. Notice down here we didn't cancel anything. We still see our 4 factors. Here we're going to write it with how many 3's are remaining, so the product as a power. Remember, when it says as a power, that means you need to have the base and an exponent. So anytime you see that direction, write as a power, that means base and an exponent. So here we're going to have 3 to the second. So what is very important is when you do this one is that the parenthesis stays as part of your problem. So we're going to have parenthesis -4 raised now to the first power. Now a lot of times people will just write that as -4, which is also understood, but remember that whole thing is being raised to a power. So -4, and it's understood to be a 1. In this last one, you're actually left with x to the 4th divided by 3 to the 4th. Since the bases are not the same, you're going to leave it and not subtract those or do anything with them. So it says now we want to summarize the pattern. So as you look at each of these, what are we actually doing with the numbers 8 and 3 to get the 5, 5 and 3 to get 2, 3 and 2 to get 1? And when the bases are not the same, we're kind of leaving that answer, right? We're not doing anything with it. So from the first to the last column in general, we see that we are going to do, and I want you to think about it before you see this in the video. So what we're actually doing is if you subtract the exponents in column 1, or in the original problem, maybe we should say, but remember, we can only subtract the exponents in the original problem to get the exponent in the last. Only when they have the same base. If they don't have the same base, it stays the same. So keep in mind, you might want to put down not the same base, no subtracting. Just keep it the same. So this is your time to practice. Again, thinking about our rule. I like to show the work this way. I know some of you that are opposed to showing any work for me would prefer not to do this, but this is what we're thinking of. The base is 3. The exponent is 6 minus 2, which gives us an answer of 3 to the 4th. Please do the next 3. Pause the video while you do that, and then we'll start it up again. One of the first questions that I kind of have people think about is that this, remember, is 9 to the 1, so that is 3 minus 1. 9 to the second is our answer. Now, since it asked us to leave our answer as a power, we need the base and the exponent, so I need 9 to the second. I do not want you to tell me that it's 81. 3 to the 4th, not telling me that it is 81. X to the first or x, both are correct answers, and then the last one stays as it is. So, as you finish watching the video, your assignment will be to do the worksheet, and we will take a look at that and go through it as we are working in class. This first one you might be doing on your own.